All right. Hello, students. How are you all? Good morning to all. Firstly, come and join in the live so that we can start today's class. Firstly, come and join. Don't waste the time. All right. So now, before joining everyone, let us start discussing on that introduction, or just we can recapitulation we'll do for the last class. Okay. Come and join fastly, students. So I'm waiting here for you all. So you just inform to me where are you all and whether what about voice clarity and all thing. Kusum and Kushipal, Garma Singh, Sahil, everyone come and join. All right. Anyhow, before going to start our class, let us close our eyes and let us do the prayer first. Then we will start. Anyhow, 60 seconds I'll give time so that everyone can come and join. All right. All right. Kusum said good morning. Very good. And who are remaining? Just say there good morning first so that I get to know. Kusum, kindly inform to your old friends so that let us start. Anyhow, Vinod said good morning. Okay, good morning, Vinod. How are you? All right. Let us close our eyes. Let's start the prayer. Then we'll start. God kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. All right. So, Kusum, kindly inform to your friends so that let them come. So, Vinod will inform to the boys so that let them come and join. Okay. All right. So, what we discussed yesterday, just we'll recapitulate that. Then we will go for our today's class work. So check now whether the clarity is good or video is good or not. Inform to me, Vinod and Kusum. Inform to me how is that video and whether it is clarity is good, voice is good, everything is fine. Small manner you are getting, or it is completely the full screen mode you are getting or not. Just check. Inform to me. Then we'll start our class. Firstly, clears are said by Kusum. Okay, then what about Vinod? Yours there clear, voice is clear, so everything is clear, then we'll start. Inform to you. Yesterday again I was called to you, the boys also, and they said that yes, sir, we are going to join, but what happened I don't know. Okay, all right. Okay, so yesterday we discussed what is continuity. So simply I was explaining to you, without lifting your pen, if you draw a graph, maybe the curve or maybe the straight line, then that is called as continuous function. This is, we can say that normal. And but what is the mathematical definition for that continuity means? Suppose f is a real function on a subset of the real numbers. So that means function should be a real numbered function. Okay, and it is subset of the whole real numbers. Then if C be point in the domain of F, domain means that is input of F, then F is continuous. Only the condition is that limit extends to C. Here it is left limit and right limit both together. Okay, limit extends to C. F of x is equal to f of c happened, then we can say that function is continuous. So you have to remember this and this. So to the situation, we have to apply these two formulas. Okay. So limit extends to c minus f of x. That is nothing but left hand limit is equal to right hand limit. This is c plus means right hand limit. That is equal to function at that point c. So these are equal to each other. Only we can say that function is continuous. Okay, this we discussed yesterday and some of the examples we solved. And today we are going to solve completely. And you are going to get today these notes. So in this, I was already complete notes was given for you all. So up to full examples are solved. So this will be given to you today. So you just go through it, and as it is, you have to write in your notebook. Okay. So that is about it. And let us start our examples from number 1. Okay. So if any problem yesterday we discussed, inform to me so that I don't want to solve again. Okay. Right. So let us go for that. Right. So your first question, check the continuity of the function f given by f of x is equal to 2x plus 3 and x is equal to 1. So here they say check the continuity of f of x is equal to 2x plus 3 at x is equal to 1. Is this explained yesterday or we need to explain? Firstly inform to me. Is this explained yesterday? If not explained, inform to me so that we will continue that. Firstly, Vinod and Kusum inform to me. Where is the Kusipal is not coming? Kushipal and Garima Singh today. Firstly, inform to me this problem yesterday was explained or not. If not explained, I am going to explain now. So we need to check the continuity. Explained. Okay. So first question is finished. Then let us go for second. Examine the function f given by f of x is equal to x square continues at x is equal to 0. This question, second question. Now example number 2. Tell to me whether it is solved or not. I hope so. We are not solved, right? Okay. Let us start this. So now here first we need to go for the second method. We are not going for the first method. We are going for the second method. So in that, what we'll do first? First, we'll find f of 0. We'll write here at x is equal to 0. So we are checking the continuity. Okay. At x is equal to 0, f of 0 is equal to 0 square. That is nothing but 0. So f of 0 is equal to 0, equation number 1. And now let us go for second one now. So how to solve second one? So now second one it is limit x tends to c f of x we need to find out. Because what is our formula? Limit x tends to c f of x is equal to f of c happened. Then function is continuous. If it is not happening, function is not continuous. Here c is nothing but the given value. Here x is equal to 0 given. Just substitute wherever c is there in that place 0. So f of 0, 0 square. 0 square is nothing but 0. Next, what is next on left side? Limit x tends to c f of x. So just as it is written now, limit x tends to c is nothing but here what? 0. So substitute 0. F of x means what do you know? X square. So write that x square. So after writing this, just remove the limit and wherever x is there, substitute 0. So now 0 square. So that is equal to 0. So this is equation number 2. Now you can write from 1 and 2, from 1 and 2, limit x tends to 0, f of x is equal to f of 0. Okay, instead of c, we need to get 0 because here at x is equal to 0. Therefore, f of x is continuous at x is equal to 0. Understood now? So, that is about your problem number 2. Everyone understood? First, Kusum, you all understood or not? Very good. Kusum said continuous. You all understood or not the second one? If you are understood, keep that down symbol so that I can understand. So we'll go for next. Yes, sir. Okay. So now we'll go for third problem. So there are 18 questions are there. So we need to complete those one. So let us see how it is possible to complete. Right. Now no need to write that it's just notes is given to you. Just go through it and complete it later. So now just you have to listen. That's it. All right. Next third question. Discuss the continuity of the function of f given by f of x is equal to modulus of x at x is equal to 0. So we need to check whether the function is continuous at x is equal to 0 or not. So before going to discuss that, we need to know what is the modulus function. So you know that modulus function f of x is equal to, if x is less than 0, it is minus x. X is equal to 0, it is 0. Another one, if x is greater than 0, it is going to be x. So remember result. Okay. So first one is what? If x is less than 0 minus x, if x is equal to 0, 0, if x is greater than 0, x. This is your modulus function, which was discussed in last class. Okay, in 11th class we were discussed about this in functions. Anyhow, let us solve this problem now. So here, how many conditions you are finding? Three conditions. So three conditions means left hand limit, right hand limit, function at that point. So let us see now how to solve this. So now first let me find f of 0. So at x is equal to 0, what is answer? 0. So just keep 0. Equation number 1. So next one we need to go for remaining 2. So left hand limit. Left hand limit. Limit x tends to 0 minus f of x. So now limit x tends to 0 minus f of x means what do you know here? So less than 0. So 0 minus means what? Less than 0. Less than 0 means what do you know? Minus x. So just write here minus x. So now minus as it is. So when you remove the limit, wherever x is there, keep 0 because here 0 is there. So minus 0. Minus 0 is nothing but 0 only because because this 0 is neither positive nor negative. Means it is not positive, not negative. Remember that. So now this is give us equation number 2. Next. right hand limit, limit x tends to 0 plus f of x is equal to limit x tends to 0 plus. Now check here, what is f of x when it is greater than 0 means? So greater than 0 is nothing but plus x. So now we can write here only the plus x. So now x plus, when you remove the limit, what will 0. So let us keep the 0 because remove this and x plus here 0, 0 we get. That is equal to, this is equation number 3 we can give. Then from 1, 2 and 3 we can write what? Limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x is equal to f of 0. Therefore, what we can say now from this? Therefore, f of x is continuous at x is equal to 0. Okay. So f of x is continuous at x is equal to 0. I hope you all understood. Once you can check this out, and if you are still having doubt, you can ask me. So for you all to write this, I'm giving for you 15 seconds. You just complete it. All right. I hope everyone understood. Yes, sir. Okay. So now finish this. Anyone having any doubt? Kusum and Vinod, Kushipal now came. Kushi, you are there? Kushipal is there or he went now? Just came, said present sir and went. Kushi, if you are there, just keep your hand there so that I can understand whether you are there or not. So this is your problem number 3. We finished now problem number 3. Now we are going to solve problem number 4. So Kushipal, just you went. So until end of the class, you should be here. Don't leave here and there so that you cannot understand anything. In mid of the class, don't leave. Yes, sir, I am in. Okay, you be there only. Don't go in here and there. I am middle. Still anyone present? So only the 2 boys are not 3 boys, right? Garima also not present. What happened to her? I don't know. And remaining Dhruv, Sahil, and Dairya. So inform to those students. Yesterday also I was informed. Okay, let us go for problem number 4. Show that function f of x is equal to x cube plus 3 if x is not equal to 0. 1 if x is equal to 0. Function is not continuous at x is equal to 0. We need to prove now is not continuous at x is equal to 0. So function given is this x cube plus 3 if x is not equal to 0. What is mean by not equal to 0? Not equal to 0 is nothing but left hand limit and right hand limit for both function is this only. Only at x is equal to 0 function is this. Okay. So I hope you are understood. Now just concentrate here now. So what I am saying. So now first let us go for at x is equal to 0 say. So first write at x is equal to 0. F of 0 is equal to, at x is equal to 0, what is function value? Can anyone say? So let me see that in the comment who is going to say first. So at x is equal to 0, what is the function value? At x is equal to 0, what is the function value? So I need answer from you all. Let me see who is going to give first answer. Whether it is Kushipal or Kusum or Vinod or I don't know remaining the students who are present. Okay, one, very good. So now f of 0 is equal to 1. Give us equation number 1. Now, left hand limit, right hand limit purpose only one I am going to use, that is limit x tends to c f of x. So then limit x tends to c. What is your f of x here? X cube plus 3. So right here x cube plus 3. Then when you remove, so anyhow c means what do you know here? 0. So right here 0. And that is equal to, whenever removing this limit, wherever x is there, substitute 0. So now 0 cube plus 3. 0 cube is nothing but 0 plus 3 is nothing but just 3. So now here give this as equation number 2. So now check here. You know that limit x tends to c f of x. F of x is equal to f of c happen, then it is continuous. Otherwise, it is not continuous. Now tell to me here f of 0 I got as 1. Limit x tends to 0. This is any of c as 0 I give. Limit x tends to 0. F of x you got as 3. Now tell to me whether it is continuous or not continuous. So now let me see from your answers. You know, according to the concept, limit x tends to c, f of x is equal to f of c. So here c is at x is equal to 0, let us, so c is equal to 0. So now just wherever c is there, substitute 0. Now f of 0 is 1, you got, limit x tends to 0, f of x you got as 3. So now tell to me, not continuous, written by Kusum. Kushipal said not. Not means what? So not continuous you have to write. Okay, very good. So now give clap to that Kusum. Kusum said first. So next, completely written by Vinod Kumar. So that for him give thumbs up. So all right, let us say write at last here from 1 and 2. From 1 and 2, limit x tends to 0. F of x is not equal to f of 0. So then we'll write at last, therefore, f of x is not continuous at x is equal to 0. Understood? Anyone having doubt? You all understood this? So understood means just keep that some symbol which is there in the comment section so that I can understand. Fast. So we need to complete today this all examples and some homeworks also I'm going to give for you all. Done? Okay. So now let us go for problem number 5. So now problem number 5. Check the points. Check the points where the constant function f of x is equal to k is continuous. So f of x is equal to k they given, and they are saying to us that check the points, means all the points you have to check whether it is continuous or not. So if it is continuous, you have to say continuous. If not, we need to say that not continuous. So then how to solve this problem? So let me know how to solve this problem. F of x is equal to k. Only this function is given. Then how to solve this? Simple. So they are given any value, not given any value. So then how to solve this? So anyhow, we can take that. So so all real numbers plus we need to check means so only one real number will take and we will check this all. Okay. Anyhow, if you know constant function, how it will be? Let me draw the Cartesian plane. X dash, y dash 0. So function f of x is equal to k for all the real numbers, means all the numbers. So this value is k. So this whole is k. Okay. So means at 0 it is k, at 1 it is minus 1 it is k, minus 2 it is k, 1 it is k, 2 it is k, 3 it is k. By observing graph itself, we will say that it is continuous. But still we need to write the procedure for this. Because of that reason, we are writing now. First, we'll find at C. At x is equal to C, where C is all real numbers, all points, otherwise, all real points. Okay. So now what I will do, just check now. So first I will go for f of C. F of C also what will get here? K only, because constant it is. So then equation number 1. Next, limit x tends to C, f of x. So because what is the condition normally? Limit x tends to C, f of x is equal to f of C. Happen it is continuous, otherwise it is not continuous. So now first f of C value is k. Why? Because so k is constant, so that we cannot change. We cannot change k as C. So it is not at all possible. That was the reason k is written. Here we can write as, if you want to write here, since k is constant. Okay. Next. So now limit x tends to C. F of x means what do you know here? K. Now there is no x in this place. Where I can substitute this say? So that just remove the limit. Whenever constant is there, we need to write only constant. So now this gives us equation number 2. From 1 and 2, we can say that f of x is continuous in at all real numbers or all real values. Okay, you all understood? Any doubt in this question? Problem number 5. Anyone having any doubt in this? So first what we done, just f of x is equal to k written. So for all the real points, by observing the graph, you can understand here that for each and every point, so the value is same, the constant. So at x is equal to c, where c is all real points we are saying, and f of c is equal to k. It is equation number 1. Why we are not changing k as c means it is k is a constant, so that we don't want to change it. And next, limit x tends to c, f of x is equal to limit x tends to c, f of x means k. Whenever constant is there, no need to keep anywhere this c, because there is no x in this. So just we are writing k as it is. Now from this 1 and 2, we can say that f of x is continuous at all real values. Y means here we need to write limit x tends to c, f of x is equal to f of c. Okay? Anyone having doubt in this, inform to me now itself. Any doubt? Vinod, Kushipal, Kusum. If you have doubt, you just keep that dislike symbol so that let me understand it. No one having doubt? Can I continue? Can I continue? Firstly, inform to me. No doubt, sir. Okay, Kusum said. Then what about Kushipal? I'm not finding a Kushipal answer. Vinod answer, Kusum answer. What about Kushipal? Firstly, to be Kushipal. And let us go for next problem. Meanwhile, okay, Kushipal answer I got. So let us go for next one now. That is problem number 6. Now you need to do this problem number 6 as it is like your problem number 5. Okay? So just to do that because instead of K they given us C. So easiest one, just to solve that. That is a homework for you. So example number 6, homework. As it is in the textbook, how it is you can write. Okay, I hope so. You are having that PDF. Now we go for 7. Seventh one is function defined by f of x is equal to modulus of x, a continuous function. They were asked a continuous function. Previously, they asked at x is equal to 0. They were asked at x is equal to 0. But now they were not mentioned anything. We need to find whether this function is continuous or not. Then how to solve this? So that time we need to go for 3 cases. What are those? Left hand limit 1, that is c is less than 0. Right hand limit c is greater than 0. Then c is equal to 0. C is equal to 0 is nothing but x is equal to 0. So you just remember those and we have to solve for all the cases. Then we can say that it is continuous. Okay. So otherwise we cannot say it is continuous. Okay. So now how to solve this problem? Just concentrate. Anyhow, f of x, we'll write it as here x minus x when x is less than 0, 0 when x is equal to 0, plus x when x is greater than 0. Correct? This only you learned? Otherwise, anything else you learned? So you all learned this one. This is called as modulus function. Now, cases wise we will solve. So now first here, if c is greater than 0, I go for c is greater than 0. Then what is your f of c? C is here greater than 0. If greater than 0 happen, what is my f of c? So c here place x is there. So that x place we need to keep as c. So f of c is equal to c. That is your equation number 1. So I hope you are understood what is this. So now whenever c is greater than 0, what is your function? F of x is equal to x. So what I am doing here, f of wherever x is there, substitute c. F of c is equal to c. That is equation number 1. So what I need to prove whenever like this is there. So always remember this only you have to prove limit x tends to c. F of x is equal to f of c. If you prove this, continues at that point. So let us see now here equation number 1. So now limit x tends to c plus. Why c plus? Because here c is greater than 0. C plus f of x f of x, or you just write only c. So c f of x is equal to, then write limit x tends to c. What is f of x when c is greater than 0? X. So just write x. So when you remove the limit, then wherever x is there, we need to substitute what? C. So just substitute c. Then this is equation number 2. Now from these two, what we can say, it is continuous function for all positive real values, or for all positive real numbers. Okay, what I said now. So you just inform to me if you have understood. I'll go for second. So here we write from 1 and 2, f of x is continuous positive real numbers. Okay, so now let us go for next. That is, if c is less than 0, go for now less than 0. If c is less than 0 means what is our function? F of x is equal to less than 0 happen. So now this is less than 0. So then f of x is equal to minus x. So write that minus x. Now let us solve. So now substitute now c. F of c is equal to minus c. Equation number 1. First we'll write that as equation number 1. So next one, limit x tends to c, f of x. So right here, limit x tends to c, f of x is equal to limit x tends to c as it is. Then f of x means when c is less than 0, what is f of x? Minus x. So just substitute here minus x. When you remove the limit, wherever x is there, substitute c. So now we can write minus c. This is equation number 2. Then from 1 and 2, f of x is continuous for all real, for all negative real numbers. For all negative, see here minus v is nothing but negative. Okay, negative real numbers. Okay, so we know what happened for the video. So you just refresh it and check once. So whether it is clarity is good or not, let me know that. So everyone quality is not good only for Vinod. Just check and inform to me fast. Kushipal and Kusum also, you just check and inform to me so that I get to know. Okay, it is loading. Loading is happening means that is because of your network issues. Because for me it was nicely is there. Let me check myself also, then I will inform to you all. Okay, so everyone same problem facing. And now check now the arrangements was the little changes are doing. So you just kindly check and inform to me what was the situation. Is there any changes in the situation or it is like that only? Kusum and Kushipal and Vinod, check now, inform to me. Are in same situation only or any changes are happening? Fast. Still it is blur. No change, sir. Okay, let us go for next video then. Okay. So you all come and join in the next live so that let me stop here this live. Okay. Okay, no problem. We know Kushipal and Kusum. So what you will do is now in my channel itself, you just go through it. So there is a new live will be so within 2 minutes. Okay. So you just join in that. I think some 15 minutes is left. So we'll complete within 15 minutes all remaining all problems. Okay. Right.